Hello again, everyone, and welcome back to Geospatial Intelligence PH channel. In this video, we will continue our workflow on hydrological analysis by focusing on how to generate a watershed using the river stream network derived from a digital elevation model in ArcGIS Pro. If you missed the previous part of this tutorial, I highly recommend watching it first, as I have provided the link in the description below to guide you through the complete process. Now, without further delay, let's proceed. To begin with, we need to create a point data set that will represent the outlet, or more technically, the pour point of the river system. The outlet is a critical location in watershed analysis, as it defines the exact point where all accumulated water from upstream areas converges and exits the basin. Accurately placing this point ensures that the generated watershed will correctly represent the contributing drainage area. To create this, navigate to your catalog pane, right-click your working folder, and select New Feature Class. Assign your desired name, set the geometry type to point, and for the coordinate system, select Current Map so that it aligns with your project's spatial reference. Once completed, proceed to create the feature class. After preparing the outlet dataset, enable your flow accumulation raster in the Contents panel. This raster provides a visual representation of how water accumulates across the terrain, where higher values indicate areas of concentrated flow that typically correspond to river channels. These visible flow paths will serve as your guide in accurately positioning the outlet point. Then, go to the Edit tab, select Create, choose your outlet point layer, and place the point precisely at the center of the pixel where the water exits your study area. This step is crucial, as even a slight misplacement can affect the accuracy of the resulting watershed. With the outlet point properly defined, we can now generate the watershed. Open the Geoprocessing pane, navigate to Spatial Analyst Tools, then Hydrology, and select the Watershed tool. In the parameters, assign your flow direction raster as the input raster and your outlet point dataset as the pour point input. Set the pour point field to the ID field, define your output location, and run the tool. After processing, the resulting raster will represent the entire area that drains toward your specified outlet. To make the output more usable for mapping and analysis, we will convert the watershed raster into a vector format. In the Geoprocessing pane, search for Raster to Polygon under Conversion Tools. Input your watershed raster, keep the field set to value, specify your output location, and enable the Simplify Polygons option to produce smoother and more visually refined boundaries. Run the tool to generate your watershed polygon. Now that we have a clean watershed boundary, we can further refine our analysis by clipping the river network within this area. Open the Clip tool from the Geoprocessing pane under Analysis Tools. Set your river network as the input feature and your watershed polygon as the clip feature, then run the tool. This process isolates the river system within the defined watershed, allowing for a more focused and meaningful interpretation of the hydrological structure. At this stage, you have successfully generated a watershed and extracted the corresponding river network from your DEM. To enhance the visual quality of your output, you may apply additional symbology, such as HILLSHADE or elevation-based color gradients to your DEM layer, which can significantly improve the clarity and presentation of your map. And that completes our workflow. I hope this tutorial helps you in your GIS projects, research, and overall understanding of hydrological analysis. If you found this video valuable, please consider liking, subscribing, and sharing it with others who may benefit from this content. Thank you very much for watching, and I'll see you in the next tutorial.